Article 695, governing fire pumps, does not apply because the air compressor is not directly powering a fire pump. Article 760.26 is relevant. It states that conductors for fire alarm systems must not occupy the same raceway as conductors for general power or light. Since the air compressor is not part of the fire alarm system, it can be installed in the same conduit with general power. Cord connection of the air compressor to a receptacle is generally not permitted. Article 760.110 prohibits the use of extension cords or flexible cords for permanent wiring of fire alarm systems. The air compressor is an essential part of the sprinkler system. It should be permanently connected to the electrical supply. A receptacle connection would not provide the same level of reliability and safety as a direct connection. It is recommended to install the air compressor feed in a separate conduit to avoid any potential interference with general power circuits. The air compressor should be connected to the electrical supply through a dedicated circuit breaker or fuse as required by Article 760.31. Let's break down each of these points further to ensure a clear understanding of the requirements and best practices for installing an air compressor for a sprinkler system. Firstly, let's elaborate on why Article 695 does not apply. Article 695 of the National Electrical Code specifically addresses the electrical installation of fire pumps. Fire pumps are dedicated pumps that provide water flow and pressure for fire suppression systems. They are critical for ensuring that the sprinkler system can operate effectively during a fire. Since the air compressor in this scenario is not directly powering a fire pump, but rather providing a backup power source for dry sprinkler system, Article 695 does not govern its installation. The primary function of the air compressor is to maintain air pressure within the sprinkler pipes, which is different from the direct water pumping action of a fire pump. Secondly, the relevance of Article 760.26 needs clarification. Article 760 of the National Electrical Code covers fire alarm systems. Section 760.26 specifically addresses the separation of fire alarm circuit conductors from general power and lighting circuits. This separation is crucial to prevent electrical interference or faults in the general power circuits from affecting the operation of the fire alarm system. The Code mandates this separation to ensure the reliability and integrity of the fire alarm system during emergencies. However, in this case, the air compressor is not part of the fire alarm system. It's part of the sprinkler system. Therefore, while the general principle of separating critical safety system circuits from general power circuits is good practice, Article 760.26 does not strictly prohibit sharing a conduit between the air compressor power feed and general power circuits. The key is to ensure that the air compressor's operation does not compromise the functionality or safety of the fire alarm system if one exists separately. Now, regarding the prohibition of cord connection. Article 760.110 explicitly prohibits the use of extension cords or flexible cords for the permanent wiring of fire alarm systems. This prohibition is in place to ensure the reliability and safety of the fire alarm system's power supply. Extension cords and flexible cords are generally not designed for permanent installation and can be susceptible to damage where an accidental disconnection. For a critical system like a fire alarm, a permanent and secure wiring method is essential. In the context of the air compressor for the sprinkler system, even though it's not directly part of the fire alarm system, it's an essential component of the sprinkler system's functionality. A sprinkler system relying on an air compressor needs a reliable power source to maintain air pressure in the pipes. Using a cord connection to a receptacle introduces potential points of failure. The cord could be accidentally unplugged, damaged, or the receptacle itself could fail. These failures could compromise the sprinkler system's ability to operate when needed. A direct, permanent connection provides a more secure and dependable power supply. Finally, the recommendation to install the air compressor feed in a separate conduit. While sharing a conduit with general power circuits may technically be permissible under certain interpretations of the code, it's generally recommended to install the air compressor feed in a separate conduit. This practice provides several benefits. Firstly, it minimizes the risk of electrical interference between the air compressor circuit and other circuits. Secondly, it simplifies troubleshooting and maintenance. If there's a problem with the air compressor circuit, it can be isolated without affecting other circuits in the same conduit. Thirdly, it provides a clear separation between the sprinkler system's power feed and general power circuits, which can be beneficial for future inspections and modifications. Furthermore, the air compressor should be connected to the electrical supply through a dedicated circuit breaker or fuse, as required by Article 760.31. This dedicated circuit breaker or fuse provides overcurrent protection for the air compressor circuit, preventing damage to the equipment and minimizing the risk of electrical fires. It also allows for easy isolation of the air compressor circuit for maintenance or repairs. In summary, when installing an air compressor for a sprinkler system, ensure the following points. Firstly, confirm that Article 695 does not apply, as it governs fire pumps, not air compressors for sprinkler systems. Secondly, understand the implications of Article 760.26 regarding the separation of fire alarm circuits from general power circuits, but recognize that it may not strictly prohibit sharing a conduit in this specific case. Thirdly, avoid cord connections and opt for a permanent wiring method to ensure a reliable power supply for the air compressor. Fourthly, consider installing the air compressor feed in a separate conduit to minimize interference and simplify maintenance. Fifthly, provide dedicated overcurrent protection for the air compressor circuit using a circuit breaker or fuse. By following these guidelines, you can ensure safe and reliable installation of the air compressor for the sprinkler system, promoting the overall effectiveness and safety of the fire protection system. Now, let's delve into some additional considerations and best practices for installing air compressors in sprinkler systems, focusing on aspects beyond the specific code articles mentioned. Firstly, let's talk about the selection of the air compressor itself. When choosing an air compressor for a sprinkler system, it's crucial to select a model that is appropriately sized for the system's requirements. Factors to consider include the volume of the sprinkler system, the desired air pressure, and the compressor's duty cycle. A compressor that is too small may not be able to maintain adequate air pressure, while a compressor that is too large may be inefficient and consume excessive energy. It's also important to select a compressor that is designed for continuous or frequent operation, as sprinkler systems often require constant air pressure maintenance. Secondly, let's discuss the location of the air compressor. The location of the air compressor can significantly impact its performance and longevity. It should be installed in a clean, dry, and well-ventilated area. Avoid locations that are subject to extreme temperatures, humidity, or dust. Ensure that there is adequate space around the compressor for maintenance and servicing. The compressor should also be located as close as possible to the sprinkler system's air supply connection to minimize pressure loss in the piping. Thirdly, let's consider the piping and connections. The piping connecting the air compressor to the sprinkler system should be properly sized and installed to minimize pressure drop and leaks. Use appropriate materials, such as copper or steel, and ensure that all connections are tight and secure. Install a pressure gauge and a pressure relief valve in the piping to monitor and regulate the air pressure. The pressure relief valve is a critical safety device that will prevent overpressurization of the system. Fourthly, let's discuss the electrical considerations in more detail. In addition to providing a dedicated circuit breaker or fuse, it's important to ensure that the electrical wiring is properly sized and installed according to the National Electrical Code. Use the correct gauge wire for the compressor's amperage rating and ensure that all connections are properly made and insulated. Ground the compressor properly to prevent electrical shock hazards. Consider installing a disconnect switch near the compressor to allow for easy isolation of the power supply during maintenance. Fifthly, let's talk about maintenance and testing. Regular maintenance is essential to ensure the reliable operation of the air compressor. Follow the manufacturer's recommendations for maintenance tasks, such as checking the oil level, cleaning the air filter, and inspecting the belts and hoses. Periodically test the compressor's performance to ensure that it can maintain adequate air pressure in the sprinkler system. Keep a maintenance log to track the maintenance activities and test results. Sixthly, let's consider the integration with the fire alarm system. While the air compressor may not be directly part of the fire alarm system, it's important to ensure that its operation does not interfere with the fire alarm system's functionality. For example, the compressor's electrical noise should not cause false alarms. If necessary, install filters or surge suppressors to minimize electrical interference. Coordinate the installation and testing of the air compressor with the fire alarm system to ensure compatibility. Seventhly, let's discuss the documentation and labeling. Properly document the installation of the air compressor, including the wiring diagrams, piping layouts, and maintenance procedures. Label all components clearly, including the circuit breaker, disconnect switch, and pressure relief valve. This documentation and labeling will make it easier to maintain and troubleshoot the system in the future. Eighthly, let's consider the local codes and regulations. In addition to the National Electrical Code, there may be local codes and regulations that apply to the installation of air compressors in sprinkler systems. Check with the local authorities to ensure that the installation complies with all applicable requirements. This may include obtaining permits, inspections, and approvals. Ninthly, let's discuss the emergency power considerations. In some cases, it may be necessary to provide emergency power for the air compressor to ensure that it can operate during a power outage. This can be accomplished by connecting the compressor to an emergency generator or an uninterruptible power supply UPS. The emergency power system should be designed to provide sufficient power to operate the compressor for the duration of the power outage. Finally, let's consider the environmental impact. Air compressors can consume a significant amount of energy. Choose energy-efficient models and implement energy-saving practices to minimize the environmental impact. For example, use a variable speed compressor that adjusts its output to match the demand, or install a timer to turn off the compressor when it's not needed. By considering these additional factors and following best practices, you can ensure a safe, reliable, and efficient installation of an air compressor for a sprinkler system. Remember to consult with qualified professionals such as licensed electricians and fire protection engineers to ensure that the installation complies with all applicable codes and regulations. In the realm of air compressor installations for sprinkler systems, understanding the nuances of codes and best practices is paramount. Let's further expand on some critical aspects to ensure comprehensive knowledge and adherence to safety and efficiency standards. Firstly, let's explore the grounding and bonding requirements. Proper grounding and bonding are essential for electrical safety, preventing shock hazards and ensuring the proper operation of electrical equipment. The National Electrical Code Article 250 provides detailed requirements for grounding and bonding electrical systems. For the air compressor, ensure that it is properly grounded by connecting it to the building's grounding electrode system. This typically involves connecting a grounding conductor from the compressor's metal frame to the grounding busbar in the electrical panel. Bonding refers to connecting all metal parts of the electrical system together to create a low impedance path for fault current. This helps to ensure that overcurrent protection devices, such as circuit breakers, will trip quickly in the event of a fault. Bond all metal conduits, enclosures, and equipment associated with the air compressor to the grounding system. Secondly, let's consider surge protection. Air compressors, like other electrical equipment, are susceptible to damage from voltage surges caused by lightning strikes or other electrical disturbances. Surge protection devices (SPD) can help to protect the compressor from these surges. Install an SPD at the electrical panel that supplies power to the compressor. This will help to divert surge current away from the compressor and protect its sensitive electronic components. Consider installing additional SPD at the compressor itself for added protection. Thirdly, let's discuss the overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current that could cause overheating and fires. The National Electrical Code Article 240 provides requirements for overcurrent protection. Select the appropriate size circuit breaker or fuse for the air compressor's circuit based on its amperage rating and the wire size. Ensure that the circuit breaker or fuse is properly installed and labeled. Test the circuit breaker periodically to ensure that it is functioning properly. Fourthly, let's delve into the wiring methods. The National Electrical Code Chapter 3 provides detailed requirements for wiring methods. Use appropriate wiring methods for the air compressor's installation, such as rigid metal conduit RMC, electrical metallic tubing EMT, or flexible metal conduit FMC. Ensure that the wiring is properly supported and protected from physical damage. Use the correct size and type of wire for the compressor's amperage rating and voltage. Make all wiring connections in approved electrical boxes or enclosures. Fifthly, let's consider the control and monitoring systems. Air compressors used in sprinkler systems often require sophisticated control and monitoring systems to ensure proper operation. These systems may include pressure sensors, flow meters, and control valves. The control system should be designed to automatically start and stop the compressor as needed to maintain the desired air pressure in the sprinkler system. The monitoring system should provide alerts if the compressor malfunctions or if the air pressure drops below a certain level. Integrate the control and monitoring system with the building's fire alarm system to provide comprehensive fire protection. Sixthly, let's discuss the noise and vibration control. Air compressors can generate significant noise and vibration, which can be disruptive to building occupants. Install the compressor on vibration isolation mounts to reduce the transmission of vibration to the building structure. Enclose the compressor in a soundproof enclosure to reduce noise levels. Consider locating the compressor in a remote area of the building to minimize the impact of noise and vibration on occupants. Seventhly, let's consider the accessibility and maintenance. Ensure that the air compressor is easily accessible for maintenance and repairs. Provide adequate clearance around the compressor for servicing. Install a service outlet near the compressor to provide power for maintenance tools. Keep a supply of spare parts on hand to minimize downtime in the event of a failure. Eighthly, let's discuss the training and documentation. Provide training to building personnel on the proper operation and maintenance of the air compressor system. Develop comprehensive documentation for the system, including wiring diagrams, piping layouts, and maintenance procedures. Keep the documentation up to date and readily available for reference. Ninthly, let's consider the energy efficiency. Air compressors can consume a significant amount of energy, so it's important to select energy-efficient models and implement energy-saving practices. Use a variable speed compressor that adjusts its output to match the demand. Install a timer to turn off the compressor when it's not needed. Regularly maintain the compressor to ensure that it is operating efficiently. Finally, let's discuss the environmental considerations. Air compressors can have a negative impact on the environment if not properly managed. Dispose of waste oil and filters properly. Prevent leaks of refrigerant or other harmful substances. Use environmentally friendly refrigerants and lubricants. By considering these additional factors and following best practices, you can ensure a safe, reliable, efficient, and environmentally responsible installation of an air compressor for a sprinkler system. Remember to consult with qualified professionals such as licensed electricians, mechanical engineers, and fire protection engineers to ensure that the installation complies with all applicable codes and regulations. And remember that while sharing a conduit might be permissible, separating circuits offers enhanced safety and easier maintenance.